In this tutorial, you will learn about the definition of force as well as the common examples of forces. Now let's get straight to the definition. So it says here, force is an interaction between two bodies or between a body and its environment. Now take note that when you use the term interaction, what it means is that it's something that's reciprocal or mutual. There's a reciprocal or mutual action. So, example, when one object does something on the other, then the second object also gives back to that first object. Unlike your crush who may not have the same feeling. Just kidding. So, example, in this case, these gentlemen push the car forward, and as a result, the car pushes them back. And they would feel that, of course, because if you are one of these men pushing this car, you would actually feel that it may get painful as you push the car forward using your bare hands. Now, take note that force is not only between two bodies, it could also be between a body and its environment. So, example, for air resistance in this case, the parachute as well as the person itself are both interacting with the air molecules, their environment. And of course, while we don't see force as it is not a tangible object, we see the effect of air resistance in this parachute system because obviously it is slowed down by the air. So again, force is not something tangible. We don't see force, but we can only see its effects on the object that experiences this force. Take note that force is also defined as a push or a pull, especially from grade school teachers. Most probably they use this simple definition, which makes sense as well because these interactions take place through a push or a pull. So in the case of the car earlier, the men push the car forward and the car also exert a force towards these men. And then here, the air molecules push the parachute upward, and then the parachute also exerts a downward push on the air molecules. But of course, it's not just a push, it may be a pull as well, like the Earth's gravity that pulls satellites towards the Earth's core. However, these satellites do not just readily fall to the ground because they are designed to have very high horizontal velocities, allowing them to orbit the Earth instead of falling towards its surface. And then another example, in planetary systems like the solar system, the sun, which is super massive, exerts a strong gravitational force that attracts these planets. That's why they are able to maintain their respective orbits. Take note as well that force is a vector quantity, meaning to say it has magnitude and direction. So for example, you're dealing with a physics problem that looks like this, then you can say that these men are pushing the car leftward and the car is exerting a rightward push on these men. And this allows you to observe proper sign conventions when dealing with word problems. So take note that force is always directed towards a specific direction. And then for the units, please take note of this. The SI unit of the magnitude of force is the Newton, named after Isaac Newton. And then the abbreviation is capital letter N. Also remember that 1 Newton is equivalent to kilogram meters per second squared. Why is it important? Well, when you perform calculations, you may not properly come up with the final unit correctly if you don't know that 1 Newton is equivalent to kilogram meters per second squared. So by making yourself aware of these equivalent units, you can do proper cancellations when you are dealing with physics problems involving forces. So that's it. Take note as well that there is this what we call a spring balance that you're probably familiar with, and that is used to measure force. So remember that while we don't see force, we see its effects, and definitely we can quantify force for practical purposes. So in this case, if you hang an object on the hook of this instrument, say for example, you hang a handbag on it, and let's say it reads 6 newtons, for example, it means that the gravity of the earth pulls the handbag downward with a 6 newton magnitude of force. As a result, the handbag is actually pulling this instrument as well with a 6 newton force, which is technically just its own weight. Now, take note that there are some common types of forces in physics that you have to be aware of so you can easily analyze conceptual and mathematical problems in dynamics. First is normal force. Miss, why is it called normal force? Is there an abnormal force? No, in fact, normal means perpendicular to, because normal force is just a force that acts perpendicular to the surface of contact between the two bodies involved in the interaction. So for example, when you rest a book on a table, because you don't want to review for physics, the book exerts its weight against the table. And as I've mentioned earlier, forces are reciprocal or mutual. So this table exerts back an upward force against the blue arrows, okay? So that force is what we call as normal force, represented by letter N. Capital letter N for this illustration. By the way, just to avoid confusion, when you look at online references, a lot of them use capital letter N. But whenever I look at textbooks, especially those college level textbooks, they usually use lowercase of the letter N. And just listen to your teacher because it's important that you all have an agreement as a class so you don't get confused. But personally, as a teacher, I prefer using the small letter N for normal force because if you use capital N, you might confuse it with the unit for force, which is Newton. Okay, so that's it. And then for the purpose of problem solving, especially when you're drawing free body diagrams, remember that in the case of inclined plane, the normal force, again, is perpendicular to the surface of interaction. So if your inclined plane looks like this, so it's, of course, it's slanted, it's an inclined plane, then the normal force would not be pointing vertically upward. So the normal force would be perpendicular to the surface of interaction. So if your inclined plane looks like this, then the normal force would be this arrow. So also another abbreviation for normal force is F sub n. So again, make sure that you pay attention in class so you know what your specific teacher prefers to use to represent or to abbreviate normal force. Is it small letter n, capital N, or F sub n? But just so you're aware, those are the possible abbreviations for normal force. Another common type of force we encounter in physics is friction. Now, it is just the force which opposes the relative motion between two surfaces in contact with each other. Now, because of the use of the term motion in the definition, I noticed that some students, they have this misconception that friction only takes place when the object is in motion. However, that's not always the case. So, example, there is a box or whatever object it is, and then you try to push it by applying a force in this direction, let's say rightward. If this box remains stationary, take note that there is still what we call as static friction that you are actually struggling to overcome. Miss, why does this static friction exist? And also, Miss, what if the floor is super smooth? Well, there's still a friction called static friction, even if the surface is shining, shimmering, splendid. So just to explain that, if you have two surfaces that are in contact, example, the box and the floor in the slide presentation, then the molecules exert what we call as intermolecular forces on one another. So if these are the two surfaces in contact, these molecules are attracted with one another because they carry charges in them. So that resistance, when you're trying to pull something towards a specific direction, the resistance is caused by the attractive intermolecular forces, and that is actually what's causing or what we call as the static friction. Is what if I apply a rightward force on an object and I get to move it rightward? Well, then congratulations, you've successfully overcome the static friction caused by these sticky molecules. And what's present now is just the kinetic friction caused by the super quick or momentary interactions between the molecules and caused as well by the irregularities of the surface. Let's say the floor or the box itself has some irregularities. They're not perfectly smooth. So that's why you have kinetic friction. Take note that for a specific pair of bodies, example, wooden box against concrete ground, static friction is generally higher than kinetic friction because these intermolecular forces are obviously more effective when the object is at rest, okay? So what's happening when you are pulling something? Let's say, for example, this is in motion, chemistry book against physics book, you're sliding them against one another. What you're doing is you're basically disrupting these intermolecular forces between the molecules consistently. In most cases, static friction is higher than kinetic friction. Usually, it's higher to set the object in motion, but once you've set something in motion, once you've overcome static friction, it's easier to keep it moving than to set it in motion to begin with. It's because of this fact. It's because of the fact that generally, static friction is higher than kinetic friction. After friction, next we have tension force, or you can simply say tension. So in the case of tug of war, the tension force is acting in both directions because both teams would be pulling on the rope. And then in this pendulum, the tension force is directed upward, represented by this blue upward arrow, because it basically keeps the mass suspended in the air, even if there is gravity pulling it down, given by mg. The last type of force we're going to talk about is weight, which is simply the pull of gravity on an object. So when you step on a bathroom scale, for example, the higher the reading is, the stronger the Earth's gravity is pulling you down. So don't feel bad if the reading is high, it's just that gravity is too attracted to you. Now, take note that weight varies across different celestial bodies. So if you go to Mars, for example, your weight would be just 38% of your weight on Earth, because the strength of gravity of Mars is only 38% of the Earth's gravitational strength. However, your mass is the same because mass is the amount of matter in your body. Now, take note that among the 4 common types of forces, 3 of those are considered as contact forces, including normal force, friction, and tension, meaning to say they require direct physical contact for the interaction to take place. On the other hand, non-contact forces like weight can act even when the bodies are separated by empty space. Another example of non-contact force is the attraction between magnets. However, take note that this video will not expound that further, as these forces are thoroughly discussed in separate physics lessons like gravitation, as well as topics on electromagnetism. Also, remember that you have to be well aware of both categories of forces when you analyze physics problems. You won't miss any of these forces when setting up sketch or a free body diagram. Now, shown in this slide are the typical magnitudes of forces. Example, the force exerted by the sun is this big. That's why the sun keeps the Earth, as well as the other planets, in their respective places or orbits. So take note that generally, the greater the masses involved, then the higher the gravitational force is. You can also see that the exponent of the base 10 goes into negative values when we deal with extremely small bodies like weight of the smallest insect eggs. The electric attraction between proton and electron in a hydrogen atom has a magnitude of 8.2 times 10 raised to negative 8 newtons, so pretty low. So what I want you to take note is this 1 Newton apple. Miss Y, do you love apples? That's true, but it's also because my purpose really in showing you this table is to encourage you to evaluate your answer when solving physics problems. So for example, when you put a medium apple on the palm of your hand, the force or weight that you feel against your hand is roughly 1 Newton. So at least you have an idea how strong 1 Newton is. Just imagine a medium-sized apple in your hand. So what, miss? Well, when you solve physics problems where force is the target variable, you have to gauge if your answer is reasonable by using this apple as a reference. So when there's a physics problem and the required to find is a person's weight, for example, in Newton, will you be convinced if, let's say, for example, you get an answer that's roughly 10,000 newtons and you're solving for a person's weight in that physics problem? So would you think that a person's weight could be 10,000 times the weight of this medium-sized apple? So if you get an answer for a person's weight that is roughly 10,000 newtons, you have every reason to doubt the correctness of your answer, because like a person's weight is not likely to be 10,000 times the weight of an apple, right? So that's too high. And whenever that is the case, you should review your solution, because most probably your solution is wrong or something is wrong in the problem itself. Maybe your teacher had a typo error in the given variables. So again, be familiar with this typical force magnitude, especially this 1 Newton apple. So when you solve physics problems, you'll have a better sense of judgment if the answers you're getting are likely to be correct based on their magnitude. And then here's the summary of the concepts. You may copy them or take a screenshot. Thanks for watching and have a great day.